Hey, welcome back to your favorite technical mathematics class. We're going to talk about volume of rectangular solids today: cylinders, pyramids, cones, spheres. So we've looked previously at like perimeter, like 3 plus 2 plus 3 plus 2 is 10. We got perimeter of 10, or maybe let's say it's feet. And then we looked at area, which is length times width for a rectangle, so 3 times 2, and that gives you the area, that'd be like 6 square feet. And now we're going to do volume, so that would be for a rectangular solid, length times width times height. Okay, so here's a rectangular solid, length times width times height, or side times side times side, and that's telling you like how many, for a rectangular solid, let's say this is a pool, and I don't know, it's like 6 feet by 3 feet, whatever. I know this is not realistic, but when you end up with 108 square feet of water in there, and this is showing you how many cubic units you would have. There's 108 of those things. So that's volume. Let's find the volume here. You got length times width times height. You got 20 times 8 times 16, and this is centimeters times centimeters times centimeters. This ends up being 2560 cubic centimeters. Centimeters times centimeters times centimeters. For a right cylinder, you've got pi r squared, which is the area of the base, right? Pi r squared, area of the base, and then it's times its height there. That'll give you the volume for a right circular cylinder. So pi times the radius squared times the height. So we're going to use 3.14 for the pi. Our radius here, since it's got a diameter of 11, diameter is all the way across. So the radius would be half of that. So the radius would just be 5.5. Half of the diameter, so 5.5, and this is meters. So that's squared, the radius is squared, and then the height's 14. And just make sure you punch in that 5.5 squared first. So that ends up being 30.25. And then multiply it by the 14. And then times the 3.14. And you end up with 1329.79. So the volume is 1329.79. And it looks like this is meters, so it'll be cubic. It'll be always, for volume, it's always going to be cubic, m cubed in this case. Because what's happening is your meters are squared, and then times another meter with that height there. So this is square meters right here, and then times another meter, cubic meters. Now if you're rounding to the nearest tenth right there, you're rounding to this 10th position, you look at that 9 right there and you say, well, if it's 5 or more, I got to bump that 7 up. If it's 4 or less, I just let it rest. So 1329.8. Again, 5 or more, add 1 more. 4 or less, let it rest. So you always look to the right when you're rounding, just as a reminder of that. Volume of a pyramid is 1/3 the area of the base. That capital B means the area of the base. So if you've got like a square base on the bottom, it'd just be the length times the length, and then it's times the height. So area of the base times the height. So for example, if you take the Luxor Hotel here in Las Vegas, and it's the base is to be based on the same shape as the Great Pyramid of Giza, let's find if it's actually as big or as large. So the volume of the Luxor, if it has a square base length of 600 feet. So this is 600 feet, this is 600 feet, and then the height is 350. So let's plug it in. 1/3. Again, the capital B is the area of the base. So that's 600 times 600 because it's a square base there. And then times the height's 350. So I'm going to go 600 times 600, so 360,000 times 350. And let me do that. Times 350, and then I'm going to take 1/3 of that, so divide by 3 here, and it looks like you end up with 42 million on that. And we are in feet cubed, cubic feet. So that's the Luxor. That's the size of the Luxor, the volume. Now the question is it as big as the actual Great Pyramid of Giza? Well, the Great Pyramid of Giza is 91,227,778 cubic feet, so substantially larger, interestingly enough. Makes you want to go see the Great Pyramids. All right, the volume of a cone. Well, a volume of a cone, you got this one-third pi r squared times the h. So you got to know the radius, you got to know the height to plug that in there. For a sphere, 4/3 pi r cubed, so you got to know your radius for that. So let's do some here. Find the volume of a cone with a radius of 3. So find the volume of a cone. Oops, it's got a radius of 3, and it's got a height of 9, So if you go back, you say, oh, well, it's 1/3 pi r squared h, 1/3 pi radius squared times the height, and then you punch that in. Make sure you use 3.14 for that and round to the nearest tenth on that. That'll end up being 84.8, and we're in meters cubed, it looks like. So that's your volume there. Find the distance and volume between a basketball with a diameter of 9.51 and a volleyball with a diameter of 8.39. Well, the volume of a sphere, if you look back here, is 4/3 pi r cubed. So you got to know the radius. But they say for this basketball, it's got a diameter, right? So they're giving us all the way across is 9.51. So we got to cut that in half first. So if it's 9.51 all the way across, then the radius would just be for this basketball, right? That's for the basketball. Then the radius would be 4.755 if I put that in half. So for the basketball, our volume will be 4/3 times 3.14 times 4.755. This is cubed. Now make sure when you punch this in, you do 4.755 cubed. So 4.755 times 4.755 times 4.755. You're doing it 3 times, right? Because it's cubed. Then times the 3.14. And then times the 4 on the top. And then divide all that by 3. And you get 450.111. I'm rounding that to that 1,000th place. Now let's do it for the volleyball. So volume 4/3 pi radius. Now it says diameter, so I got to cut that 8.39 in half. Again, because they're giving us the diameter. So 8.39 divided by 2, 4.195. So again, 4/3 pi radius cubed times the, I'm sorry, 4/3 pi times the radius cubed. What am I doing? There's no height with the sphere. And then we punch this in. So 4.195 cubed. So do that 3 times. Then times 3.14. Then times the 4. And then divide it all by that 3 on the bottom. Because remember, all these are over 1. You get 309.075. So what's the difference? Well, the difference, basketball's bigger. You get 450.111 minus 309.075. So 450.111 minus 309.075, and you end up with 141.036 cubic inches is how much bigger that basketball is than the volleyball. Well, thanks for listening. Working on volume. We'll see you next time.